This is an example of gas phase stoichiometry. Given the following reaction, 2 moles of carbon monoxide will react with 1 mole of oxygen to give 2 moles of carbon dioxide. Initially, you have a container with 2 moles of carbon monoxide gas and 3 moles of oxygen gas at a constant temperature of 25 degrees Celsius and a constant pressure of 1 atmosphere. Answer these questions. What is the final volume after the reaction is complete, and what is the partial pressure of the carbon dioxide gas? In order to answer this problem, let's first think about the chemical reaction that's occurring. At 25 degrees Celsius and 1 atmosphere pressure, we know that carbon monoxide, oxygen, and carbon dioxide exist as gases. So this is a gas phase reaction. Further, we read the reaction, 2 moles of carbon monoxide will react with 1 mole of oxygen to yield 2 moles of carbon dioxide. That's the reaction stoichiometry, or the mole-mole relationships across this chemical change. In this particular example, we are told that we have a container that contains 2 moles of carbon monoxide and 3 moles of oxygen, and at a constant temperature and a constant pressure. So let's make our reaction vessel. Okay, inside the vessel we put 2 moles of carbon monoxide and 3 moles of oxygen. We'll let these model 3 moles of oxygen. Okay, we're going to let the reaction go to completion. All right, so according to my balanced chemical reaction, for every 2 moles of carbon monoxide, I react 1 mole of oxygen. So thinking about this, I'm given 3 moles of oxygen and 2 moles of carbon monoxide. Therefore, carbon monoxide must be the limiting reagent. For every 2 moles of carbon monoxide, I react 1 mole of oxygen to give 2 moles of carbon dioxide. That leaves me with 2 moles of oxygen left over. Now, there's a lot of different ways to determine what the limiting reagent is. There are many videos on the fundamental section of this website where you can find all the different methods. In this case, we just looked at the mole-mole ratio, recognized that in this case we were given more moles of oxygen, although we needed more moles of carbon monoxide in the balanced chemical change. Therefore, oxygen is our limiting reagent. So the first question is, what is the final volume after the reaction is complete? Well, we can see from our balanced chemical equation or from our stoichiometry that if we react 2 moles of our given carbon monoxide with our oxygen, which is in excess, we know that we will, from the balanced chemical reaction, produce 2 moles of carbon dioxide. And I can write my stoichiometric relationships like this. 2's cancel, and it equals 2 moles of carbon dioxide. So mathematically, I've proven what conceptually I saw. All right, and then we know also that we have 2 moles. If we've used 2 moles of carbon monoxide and therefore we used 1 mole of oxygen, and we started with 3 moles of oxygen, then we must have 2 moles of oxygen remaining. All right, so that means at the end, from conceptually and mathematically, we have a total of 4 moles of gas in the container. So the volume, you just use the ideal gas law, PV equals nRT, and rearrange for volume. Volume equals nRT over P. And in this case, in our container, we have 4 moles of a gas. Doesn't matter that they're different gases because they're all behaving ideally. The R we'll use is 0.08206 liter atmosphere mole Kelvin times the temperature, 25 degrees Celsius, that will be 298 Kelvin, divided by the pressure, 1 atmosphere. And we see here that our mole unit cancels, our temperature unit cancels, our atmosphere unit cancels, and we're left with units of liters, 7.8 liters. So that's the total volume at the end. The second question was, what is the partial pressure of the carbon dioxide? Okay, so what is the partial pressure of the carbon dioxide? So let's go back up and look at our conceptual understanding. So we said that the pressure is going to remain constant at 1 atmosphere. Okay, and we have a total of 4 moles of gas remaining in our container, 4 moles total. The number of moles of carbon dioxide in the container is 2 moles. So the mole fraction of the carbon dioxide is equal to 2 moles divided by 4 moles, which is equal to 0.5. So the partial pressure of the carbon dioxide at the end of the reaction is equal to the mole fraction, which is 0.5, times the total pressure, which was 1. So the partial pressure is 0.5 atmospheres.